Hello and welcome to the second subtopic in the numbers overview of GCSE Maths. If you're watching this on the Teachably website, then you can just scroll down and then you will see the practice paper and the mark scheme that you can download. I highly recommend after watching this lecture to have a go at those questions and then mark them accordingly. If you struggle at any point during those questions, you can always reference back to this video. If you're watching this on YouTube, then you can also press the link in the description. It will take you to the page to then download the free resources. So I hope you do watch this video, take benefit from it, and then go ahead and attempt the questions to ensure that you understand this topic fully. We are going to be looking at the value of a digit, words and figures, so sort of taking wordly numbers or wordy numbers and translating them into maths, which is numbers, and then ordering positive and negative numbers, a place where a lot of students actually struggle with, and ordering decimals, and then we'll do some worked examples and then some things to avoid. So place value and ordering. Really, place value questions, they look simple, but they show up in some form on every single GCSE Maths paper every single year. And losing marks here is one of the most avoidable things a student can do. This lesson covers reading the value of a digit, converting between words and figures, ordering positive numbers, negative numbers, and decimals correctly. Okay, so think of these as foundations. As I spoke about in the first subtopic, these are foundations. You might not get a specific question on this topic in your exam, but it's assumed knowledge that you must have so that you can tackle more advanced topics. So this is foundational, okay? This is very important to understand before we take your maths to a different level. So like I said, the value of digit, words and figures, ordering positive and negatives, and then ordering decimals. So let's get into this. The value of a digit. So what are digits? Well, a digit is anything between 0 up to 9. So that's 0, 1, 2, 3, 4, 5, all the way up to 9. Every digit in a number has a value that is dependent on its position. So the digit really doesn't add the value. It's the position in context with all of the other numbers that will add its value. And I'll explain that with an example. So in the number, right, what is that number? That number is 27,463. An example would be the 7, let me just highlight that, the 7 right there, sits in the thousands column, so its worth is 7,000, not 7. The same idea applies after the decimal point. In 6.548, the 4 sits in the hundredths column, so its worth is 0.04. Let me explain these in two simple examples. Well, first, let's just look at this diagram, and then I will show you more in depth. So if we read a place value column, right, in this number right here, we've got the 10,000s column, we've got the thousands column, we've got the hundreds column, got the tens, and we've got the units. So this number right here, it's a 2. The digit is 2. But because it's in the 10,000s column, this value is actually 20,000 because it's 2 and then there is 4 zeros that follow it. Okay? The 7 is in the thousands column, so its value is 7,000. This right here is in the hundreds column, so it says 4, that's the digit, but its value is 400. This right here is in the tens column, so its digit is 6, but its value is 60. And this is in the units, and so the digit is actually its value, which is 3. And so if we break this number down, and we can do this with any number, if we actually take the number 27,463, we can, and I'm going to put this in a column so it's very obvious as to what's happening. If we look at this, we can write down the first digit, which is 2, and then however many digits that follow it, we put 0. So there's 4 digits that follow it, so 0, 0, 0, 0. Then underneath it, we're going to put the second digit, and then however many digits are after it, replaced with 0. So we've got 7, followed by 3 zeros. Then we'll do this for the 4. So 4, 0, 0, 6, 0, and then 3. And if we add all of this together, right, just column addition right there, we can very easily see that this is going to give us this number, 27,463. The 2 has the 20,000 value, the 7 has the 7,000 value, the 4 has the 400 value, and the 6 has the 60, and the 3 has the 3. Add those all together, you will get this number. So really, all of this is encoded into this right here. Okay, this is why position of your digit is so important. And let's very quickly do the same thing for the decimal example we were given. So we were given 6.548, and now let's look at the breakdown of this. I'm going to put the first digit, which is 6, and then I'm going to put the decimal place there, and because we've got 3 decimal places afterwards, I'm going to put 3 zeros, just so it's very obvious as to what's happening. 0, 0. Then underneath it, I'm going to add the next digit, which is 5. Now, just for convention, right, we don't have to do this, but just for convention, I'm going to put that decimal place back there with a 0 in front of it. Okay, so it's 0.5, and then followed by 2 zeros, so 0, 0. Then I'm going to put 0.0, because we're looking at the 4 now, and then after that is 0, and then the last digit is 0.08. And if we do the column addition for this as well, we can very easily see that this is going to give us this decimal number right here. And so if we are ever asked what is the value of the 4 in this decimal right here, we can very clearly see that the value of the 4 is 0.04. We don't really have to put the 0 afterwards, okay? If we want to know what the value of the 8 is, well, it's 0.008. If we want to know the value of the 6, it's 6. And so you can see the position is what's dictating the value of the number, not the digit, okay? So if you take anything from this slide, is that position decides value, not just the digit itself. It's a combination of the two that come together. Hope that all of that makes sense. Let's move on. So words and figures. This is very important, and it's all in the wording. So converting a number to words means reading off each group of digits. Okay, so we have to be very careful as to what we are hearing. So this number right here, I'm not going to read it out just yet. This number right here, this was converted from a phrase, and what was that phrase? That phrase was this one right here. So let me take this phrase and let me convert it. It says 4,000, so I'm going to put 4,000 down. Okay? Then there's a comma, then it says 600. Okay? Then it says and 8. So it says and 8. And 8 is just that. Do we see anything missing? We do. Because we know this is the thousands. It's referring to thousands. This is referring to hundreds. But there's no reference to tens, to the tens column. There's only a jump where it says and then it says 8. And so that's referring to the units. Okay? If it was referring to the tens, it would say 80. And so we can very easily now see, if we imagine that column addition again, this will be 4, 6, and then there's no tens. So there's no digit in the tens column. And so we have to put a placeholder 0 there, because then it jumps to the units, which is 8. Okay? So this is how you would convert the word into the number. It's 4,608. So this line right here is very important. because a missing place value needs a placeholder 0. And so these are the 10,000s, these are the thousands, these are the hundreds, these are the tens, and these are the units. If we say a word and we miss out the hundreds column in what we're saying, then we're just going to put a 0 there. Okay? So this right here, it says 19,000. So I know it's visualized here, but let's just run through that again, just so it makes a lot of sense. So it says 19,000. So what is 19,000? Well, 1,000 is always followed by 3 zeros. So we've got 19 followed by 3 zeros. Then it says 19,015. So let's actually get rid of that comma. 19,015. Okay. So first of all, 15. We know 15 refers to the tens units. The tens column, right? Because 15 is, by definition, 2 digits long. It's 1 and then 5. And then 19,000 is written like that. And if we can imagine the column addition again, we can very easily see that that's going to be 19. And then we made no reference to the hundreds. So we're going to put a 0 in the hundreds column. And then the 15 is the tens, right? Really, 15, if you break it down, it becomes 10 and 5, right? So it has the 10, it has the 1 in the 10 column, then it has the 5 in the unit column. So really, this is what that's going to look like. 19,015. Students often would write it out like this. They would say 19,000 and then they'd put 15 and then they'd put 0 at the end. But that's not the case. This is how you do it properly. Hope that makes sense. A missing value, a missing place value needs a placeholder 0. That's the most important thing you need to take from this slide. Let's move on. So ordering positive and negative numbers. On a number line, numbers get larger as you move right and smaller as you move left. That's the key to negatives, which a lot of students struggle with. And I promise you, just doing this small tweak is going to help you so much, because I remember when I was doing my GCSEs, this actually helped me. And even into my A-levels, if at any point I got a bit confused, I really and truly just drew out a number line to ensure that I wasn't going crazy, or just to verify my work. So it does help. So this means negative numbers can be counterintuitive. Minus 12 is smaller than minus 3 because minus 12 sits further to the left. We'll visualize this. Well, actually, it's right there. We've got minus 12 on the negative left. We've also got minus 3 on the negative left, but it's more to the right. And because on a number line, if you are more right than another number, you are bigger than that number. And so minus 3 is a larger value than minus 12. And so in inequality terms, it'd be minus 12 is less than minus 3. Okay? Or if you want to read it the other way around, minus 3 is larger than minus 12. However you want to memorize inequalities. I think someone told me once that they pictured this to be a crocodile's mouth, and if it was eating that number was larger than the number on the other side. Whatever works for you. So a safe method is to picture or sketch, and I'm going to highlight the word sketch because I used to do this all the time. Just sketch a number line if you can't imagine the numbers in your head. And place each value on it before writing the final order. Okay, so this is a perfect example of it. If I don't understand if minus 12 is bigger or smaller than minus 3, I am going to sketch out, and it doesn't have to be fancy or anything. The examiner is not going to mark you on this. This is your little working out on the side, your back of the envelope working out. You're just going to draw a little line somewhere and then just be like, okay, 0, minus 3, oh, minus 12 is all the way there. Okay, so minus 12 is more to the left of the number line than the minus 3, therefore the minus 3 is larger. Okay, so this is how I would do it. I would always recommend using number lines because it helps. It helps a lot. Okay. And on the side right here, it says minus 12 is smaller than minus 3. even though 12 is bigger than 3. Because if you can imagine it on this side, we've got 3 here, and then we've got 12 here. And because 12 is more to the right on the number line than 3, using the same rule, 12 is going to be larger than 3. So in the positives, it's the other way around. In the negatives, it's the other way around. Okay, let's move on. We're being told to order -3, -8, 5, -1, 3, and -10. So the first thing is, if we're being told to order a bunch of negative and positive numbers, is sketch a number line and mark roughly where each value sits, keeping negatives to the left of 0. So they've already given us a nice diagram. I'm just going to put a little 0 there. That's how I would start off. Then I would just draw a little line, and then I would start marking all of these things. So -8 would put it somewhere in the negatives or somewhere there. Then we'd have 5, so then we'd mark a 5 somewhere here. Then, in fact, let me just do this so that it's very obvious how I would start off. So I'll just put 0 there, and then I would go along. So -8, well, let's just say it's roughly here. Okay, we don't know if we're going to have a larger or smaller number. Let's just put -8 there. Then the next number is 5, so it has to be a bit closer to 0 than the -8. So I'm just going to put it right there. Then we've got a -1, so this is a 0, and -1 is just going to be immediately to the left of 0. And in fact, I just realized I put the 0 in the wrong place here, so let me just get rid of that so you're not confused. And then 3, and we know 3 comes before 5, so I'm going to put it roughly there. And of course it's positive, so it's to the right of 0. And then we've got -10, and -10 again is on the left side of 0, and it's actually more left than -8. So just put -10 there. And then it says read the values off from left, which, like we've said, is the smallest, to the right. And so if we look at the number line, we can see that -10, -8, -1, 0, 3, and 5. And 0 is not in the list, so we're not going to mention 0. And then make sure you double check the negatives. -10 is further left than -8, so -10 is smaller than -8. And so the answer, I'm not sure if my face is covering it, but the answer in order will be -10, it will be -8, it will be -1, it will be 3, and then it would be 5. So if you're ever given a list like this and told to order it, that's exactly how I would do it. Start with a number line. Let's move on. Ordering decimals. So line up the decimal point and compare column by column. Tens first, then hundreds, then thousands, then 10,000s. You just do the column method as is very similar to what we were doing in the first slide, and then just compare. So a common trap is judging size by how many digits a decimal has. Make sure you don't fall into that trap. So 0.96 or 0.96 looks bigger than 0.6 because it has 2 digits, right? It has these 2 massive digits, it's 96. However, 0.6 is clearly bigger if you look at the place of where the 6 is. So, you know, it has more digits, but 0.6 is 6/10, while 0.096 is less than 1/10. So, if we look at this right here, how do you compare these then? So, how do you not fall into that trap? You just draw the column. So, 0.6 is right there. And because we're comparing 0.6 to this, I'm just going to put 2 more zeros so that we can just sort of compare them. So 0 and 0. And then underneath it, I'm going to put 0.096. When we're doing this column stuff, we need to make sure we're lining up the correct columns. Because if this 6 was in line with the 0, we're not going to be comparing the correct things. We need to make sure that all the columns are perfectly in line so we don't confuse ourselves. Now, let's look at the place values. This has a 0.6. This has a 0.0. And so just immediately anyways, we can see that this has a much larger column place value. And so this is immediately going to be bigger than this number. That has a digit in a place value that is larger than the first place value they have. It's like we're comparing 600 to 90. Obviously, the 600 is going to be bigger than the 90, even though the 90 is has a bigger digit than the 6. But remember, the value is dictated by the position. And so we can immediately just see that this is going to be larger than this. And this is a perfect representation because this is the tenths, this is the hundreds. This literally has a 0 in the tenths, so it doesn't have any value there. Okay, so we can write it out like that. Let's move on. Value of the 7 in 27,463. I think we already did this example, but let's just keep on doing the example until it's boring, because that's when you know that you understand it fully. So identify which column the 7 sits in that whole number, and we can clearly see it's in the thousandths column. So the 7 is in the thousandths column, therefore a digit in the thousandths column is worth that digit times 1,000, really, right? So it's 7,000. Or you can just think about it like, you know, we've got 27,463, and we know it's going to be that followed by however many digits to the side, so it's going to be 7,000. Again, whatever method works for you, works for you. You don't have to do exactly what I say. As long as you understand the content and it makes sense in your head, then that's all that matters, because everyone's brain works differently. Let's move on to the next example. We need to order these decimals. So we're going to be doing the same thing. Line up the decimal point, compare the tenths, then the thousandths, then the 10,000ths, then the hundreds. After the tenths, the hundreds. So we just line them up, make sure the columns are nice and crisp, the lines are nice and crisp and in line, then we can very easily see all of the numbers. So you can read these, but let's just do this on the side. So the longest string is going to be 0.000. So I'm just going to write everything in that sort of format so that we're comparing apples with apples and not apples with oranges. So we've got 0.6, but remember we just want them to be 4-digit strings. So I'm going to put 0.600. Then the next one is 0.06, and then I'm going to put a 0. Then the next one is 0.66. Then I'm going to put a 0 after that. Then it's going to be 0.096. And I'm running out of space here, so I'm just going to move it slightly. And then we've got 0.609. So the first thing we can very easily see is that any of these decimal places that have a digit in the in this first column is going to be higher value than one of the decimals that doesn't have any value in that place value. And so immediately I'm just going to reorganize this so that anything that doesn't have a digit in that first column is going to go to this going to go to the bottom of the list. Okay, I'm not sure what order it's going to be yet, but we are going to do this systematically. Okay, so immediately we know that no matter what happens or whatever digit comes next, we know that these, because they have a digit in the first column, are automatically going to be bigger than these because they have zeros in that first column. Now, what are we going to do next? Well, then we look at the second column. So if we just split this up a little bit, right? In this second column, what has a digit and what doesn't? We can clearly see that in this second column, this is the only decimal that has a digit there. The others have a 0 and a 0. Therefore, because this has a value in the second column, it's automatically going to be bigger than this decimal and this decimal. And so again, I'm going to just systematically do this, say that that comes out on top, okay, because it has a digit in the first two columns, whereas these two numbers only have a digit in the first column. So that means this is automatically bigger. And then we can apply the same rule here. If we look at the second column, they both have a number there. Then we look at the digit, because what's a bigger digit, 6 or 9? Well, 9 is bigger than 6, and therefore we know that this decimal is going to be larger than this decimal, so we can move it along. Then, well, let's see, because we already know that this number is larger than these two numbers, so now we got to compare which of these two are larger. And so we then look at the third column, and this number does not have a digit in that column, whereas this one does, and so this is going to be bigger than this. And so I'm happy with that order. I know that this is the correct order as well, and so this would actually be the correct order of the decimals. So if we look at the next step here, it says 0.06 and 0.096 are the two smallest, and it's because of what I was saying. Comparing hundreds, we've got 0.06 is equal to 0.060, which is less than 0.96. So I've gone in a lot more detail, but this is sort of like a good comprehensive way of understanding what's going on. And then amongst the top three, which we were talking about, we compare the hundreds, 0.6 is the smallest, 0.609, and then 0.66. And so the order in which we do this is going to be, does it say smallest? Well, it doesn't say smallest to largest or largest to smallest, so I'm just going to assume this is saying smallest to largest because that's what the answers are saying. And so the smallest is 0.06, which we got here, that's 0.06, then 0.096, which is here, then 0.6, which is here, then 0.609, which is here, and then 0.66, which is here. So whatever method works, just make sure you're comparing column by column so that you can see what has a place value there, and if it does have a place value, is the digit bigger or smaller than an equivalent decimal, and then you reorder it in that way. Okay, it's all about the columns. It's all about the columns. Let's move on. So now it's telling us order largest to smallest, these right here. So we've got all the decimals. So it's telling us to line them all up and do all of that comparisons again. I'm just going to do exactly what I did before, hopefully a bit more comprehensively. So again, these are going to be 4 digits. So I'm going to do 0.8 and then I'm going to do 2 zeros after it, just so we're comparing apples and apples. The next one is 0.850, then the next one is 8.00, no, it's 0.8, sorry, and then 0 afterwards, and then 0.805, and then 0.858. Okay, so again, we are going to first compare the first column. If you have a 0 in this column, you are automatically the smallest. So because all of the decimals except this one right here has a digit in that first column, they are all larger than this one. So I'm going to put this at the bottom. Now, let's compare this cluster. So if we look at this cluster right here, then we look at the next column. So we all know they have the same value right here. All of them is 0.8, and so we can't see which one's bigger just by looking at this column. You have to look at the next column. Does any of them have a 0? Okay, that has a 0, that has a 0. So automatically we know that this goes to the bottom of the list and this goes to the bottom of the list, because we know no matter what, these are going to be larger than these. And so now I want to look at these and see which is larger than the other, and then we want to look at this and see which is larger than the other. If we look at this, the first column has the same digit, so the same place value. The second column has the same digit, so the same place value. And so in order to distinguish between these two decimals, we have to look at the next column. And the next column, this one has a 0, so it has no value there, whereas this one has an 8. And so really, that is larger than that number. Okay? Then if we look at this cluster right here, this is the same, this is the same, and so we have to look at the third column. The third column, we can see this has a 0, this has a value, and therefore automatically we know that is larger than this number. And so because we've ordered this correctly, we've ordered this correctly, we've ordered this correctly, we can now say that this is the order in which we have the smallest value here and the largest value here. And so if we compare our answer, it says order largest to smallest, so we would write it out from largest from left and then keep on going. So the first number we're going to write is 0.858, which they got right here. The next one is 0.85, which is here. The next is 0.805, which is here. The next is 0.8, which is here. And then the smallest is 0.08, which is right here. So we've done it in the correct order. If you don't understand what I'm doing here, or maybe I'm going a bit too fast, you can always read this right here and hopefully it would make sense. Let's move on. Okay, so we finished this topic. Okay, I think we've done enough examples. We've talked about the concepts. It's not a large topic, but you have to understand it. Things to avoid: judging a decimal as bigger just because it has more digits. For example, thinking that 0.096 is bigger than 0.6, you have to compare the columns. And if you compare the columns, you can see that this has a value in its first column, this has a 0 in the first column, therefore automatically 0.6 is just going to be larger. Ordering negative numbers the wrong way around, for example, placing -12 above -3, just because we know intuitively that 12 is bigger than 3. Remember, draw a number line. Draw a number line if this is a big problem of yours, because I can say from my own anecdotal experience, when I was struggling with negative numbers, I drew number lines. I drew number lines until it made sense to me. So use that. Missing a placeholder 0 when writing words as figures. So turning 19,015 into 19,150 instead of this. So remember, when we're reading out words and converting them into numbers, if they specifically miss out a column value, then that column has to have a 0 in it. So in this case, 19,000, and then it says and 15. And so it's missed the hundredths column immediately. And so we don't put anything in the hundreds column, we put a 0 there. And then we move on. The next one is reading the value of a digit as just the digit itself, rather than the digit multiplied by its column, for example, answering 7 instead of 7,000. So that's pretty self-explanatory. Remember when we were breaking down those numbers, we just saw that 27,463 was just 20,000 plus 7,000 plus 400 plus 60 plus 3. So if you break it down into that, it's very easy to see the value each digit holds within the context of the number. And then comparing decimals without lining up the decimal point first, which makes it easy to compare the wrong columns against each other. We did 2 big examples of those. Please go back and you can very easily see how I'm looking at the first column. Is there a 0 there or is there a digit? Okay. If there's a 0 there, then that's automatically smaller than a number or a decimal that has a digit in that. And then if you've got multiple decimals with that digit, then compare which digit size is bigger. If it's a 3 comparing to a 9, obviously the 9 is bigger than the 3. So those are things to avoid. Some final words, place value and ordering are the foundations everything else in maths is built on. Okay? Think about each of them as the rules that make every other calculation make sense, meaning you can apply them whenever you spot the certain conditions for each. Honestly, like most things in maths, it's all about practice. And if you can finish all the questions in the practice paper we have prepared for you, then you're all set. And remember, you can always look at the mark scheme to make sure you're going along the right tracks. And then you can always refer back to this video if you have a concept in there that you're struggling with. And if you are interested in GCSE Maths tuition and you want my help or anyone from the Teachably team to personally tutor you one-on-one or join some of our classes, then please visit our website. You can contact us via an email, asad@teachably.co.uk, or you can book a free call with your parent, and then we can maybe discuss where you are, where you want to get to, and how we're going to get there. And so if you do need GCSE Maths tuition, please let us know, and we have a full structured system that I'm sure you would love to be a part of, because it guarantees a grade 7 to 9. We've been doing this for 7 years. Have a lovely day. Take care of yourself. Bye.